going to present this demo session for the LabVIEW training. And this LabVIEW training is conducting by the MindMajix. They are the online virtual training platform. So about me, I am a biomedical engineer, gold medalist from an IIT airport. I am working with national instruments from 2013. Till today, I have visited more than 1,000 colleges and I have delivered lectures about the LabVIEW and product of national instruments. I am working on the LabVIEW from last 5 to 7 years. Till today, I have written so many programs, nearly 1 lakh programs. I have one blog related to the LabVIEW, that is the LabVIEW programming blog. And till today, I have written 5 books. One is my novel and 4 technical books and 3 books related to the LabVIEW. This one is the latest LabVIEW part 1. This book is nearly 1,000 copies sold out till today. And this is a CLAD preparation book. It is my guarantee 70% question will come from this. If you are preparing for the CLAD exam and you want to give CLAD in this 2020, so 70% question will come from this book. It is my guarantee 100%. And it is my third book related to system design and LabVIEW development. So it is all about me. Today's agenda is, first we will discuss about our course, then we will discuss about the course and where we can use the courses and which kind of certificate is available. Then I will show you one demonstration live experiment, and after that I will show you how can I share my content to you during the training time and how can you avail all those things. Then we will discuss and I will demonstrate one project. So our training content is first, in this LabVIEW training program, there is 30 days training program. In this training program, we will learn LabVIEW from A to Z one by one. And our main target will be LabVIEW Core 1 and Core 2. In this LabVIEW Core 1 and Core 2, we will start from the basic LabVIEW environment. And in the basic environment, we will learn how we can control the front panel and block diagram. After that, we'll go to the data type, the basic primary data type. There are 3 primary data types, numeric, boolean, and array. It will take 2 days to learn. And we will work on the primary data type. After that, we'll go to the secondary data type, derived data type, that is array, clusters, and enumerate. We will work on this kind of data type. And after that, we will learn how can we control our program in the flow-through parameters. For that, we will use the while loop and for loops. And we will learn how can we design a repetitive computational logic. Then after that, we will learn how can we create a property, how can we control the properties of our controls and indicators. Because we can control our logic, our program, by using input and output. But if you want to control your controls and indicators, control means the input channel and output channel. जहाँ से आप input दोगे and from platform which you will take the output. So that is control and indicators. We will control them by using the property node. And after that we will learn the modularity. And the modularity in the earlier time we called it sub-BI. Now it is a modularity section. Or national instruments call it code reusability. So that is sub-BI. Then plotting of data. In this plotting of data, we will learn the difference about the waveform graph, waveform chart, and the XY graph. After that, we will learn how can we store our data, whatever the data we will acquire using LabVIEW. How can we store that data in our PC, or if we have some data in our PC, so how we can call that data, how we can read that data, and how we can import that data into the LabVIEW environment for our purpose. After that, we will learn the concept of the code report generation using the report generation toolkits. And after that, we will learn how can we control the mic and other controllers, tab control, C control means how can we utilize the control portion of our front panel. Here we can create our tree. Here we can create one table. Table is just like 2D string array. Here we can manage our entities and data. And tab control is just like a tab control. When you will work, you will learn how can we use. And then we'll talk about the parallel programming. In this parallel programming, we will learn how can we transfer our data one loop to another loop. That means we will learn producer-consumer design pattern and master-slave architectures. And then we will learn about the sequential programming. And that sequential programming is like a state machine diagram. And then we will learn about the queues and notifiers. By using queues and notifiers, we will synchronize the data communication between the parallel loops. So after that, we will learn data acquisition system, how we can acquire the data. Okay, because if you are preparing for the CLAD exam, so data acquisition is a must. If you will not work with the data acquisition system and you don't have any basic idea related to the data acquisition system, so CLAD exam will be very tough. And national instruments or hardware softwares are mostly dedicated for the data acquisition system. The national instruments का जो भी चीज है, they have designed all those things and they are every year they are improvising and they are improving their quality related to data acquisition system. In this kind, National Instruments has more than 400 modules for data acquisition and nearly 3,000 data acquisition based AQ system. Then we will discuss about the CLAD exam and how you can prepare for the CLAD exam. I will explain you. Till this time, for this course curriculum, if you want to ask anything, so you can put your question in the chat section. I will clear. Then we'll move on to our next topic. I have already tell you about our agenda. So we will move on this program. So in this program, we will cover the LabVIEW 4142, modularity, data action, design pattern, data storage, project development, exe file, and application development, and we will prepare about the CLAD exam. So what is the LabVIEW 41 and 42? LabVIEW 41 and 42 is the standard lab manual and practice study material, you can say, for the National Instruments. So it is a primary and beginner stage. If you want to learn the LabVIEW, so National Instruments company will suggest you learn LabVIEW 41. And if you want to work with the National Instruments LabVIEW and you want to work with the data expert and you want to learn other things like embedded design and others, anything. So first you have to learn about the 41 and 42. 41 and 42 are designed by the National Instruments for the teaching and learning purposes. They also follow the 41 and 42. Inside the 41 and 42, you will learn the modularity, data action, design pattern, exe and project development also. You will learn under the 41 and 42. And the CLAD, for the CLAD exam, National Instruments ask a question based on 41 and 42 only. They will not ask you any question out of the 41 and 42. So scope of this technology. Now, virtual instrumentation. Okay, National Instruments LabVIEW. So LabVIEW is an acronym of Laboratory Virtual Instrument Engineering Workbench. So here you can design your project. Here you can design your concept, your idea in a virtually. Virtual means if you want to design one board for the racing, but AI based board for racing. So you want to design. So first you can design that concept in the LabVIEW platform and you can check your idea is working or not, your logic is working or not. So why we will come here? Because when you want to design one mechanical product, one physical product, so you need to invest so much money and you will buy the things from market, and when you will come to your home, you will start assembling all those things. So at that time you need to drill, drag and cut all those, and after that when you will complete your module, you will find there is something something is not appropriate, and when you want to again design on build that thing, so at that time you will face so many challenges because already you had created one structure. So that will on the way you will waste your time, your money. So if you want to design anything for the mechanical and other things, so you can create that logic using the LabVIEW. When you will design that thing using LabVIEW, so here you can drag and drop module and you can create and you can learn what is the challenges, what is the limitations. You can set the controls, you can take the data from indicators, you can write the code, you can manage the thing. That's why LabVIEW is a virtual instrumentation platform. And during this pandemic situation, people, companies and educational institutes are working on the virtual platform. They are looking forward to the virtual instrument platform. So virtual instrument platform is the future. Why? Because using this virtual instrument platform, you can teach and you can train any person from any place. Using this virtual instrument platform, you can design and simulate your idea. You can design and create your prototype. You can make a basic development version. You can create your libraries. You can create your products on the simulation versions. That's why it is the biggest scope. And I had worked with the various companies in 2013. In 2013, I went to the ISRO for the LabVIEW installation. At that time, they was working on the Mangalyaan. Now you can understand. LabVIEW is people are using LabVIEW everywhere. LabVIEW is very good for the engineers, scientists, researchers. In this time, more than 4,000 companies across the world, and in India, nearly 1,400 companies are working on the LabVIEW, like John Deere, Tata, HCL, Delhi Metro, ISRO, DRDO. Every big research center and small research center now focusing and they are updating themselves towards the LabVIEW. So this is our complete concept where we can use the LabVIEW and how we can use. If you are good in LabVIEW, so you can apply as a application development engineer, as a sales engineer, as a technical support engineer, and you can apply in any company. Like you can apply also in the Tech Mahindra, Hannibal, Siemens. You can also apply on this company if you are good in the LabVIEW and you have the basic certificate in CLAD or CLD. Now, if you want to ask anything related to this market concepts, where the LabVIEW stands, so please ask. I will solve your problem. Then we'll move on the next topic. Certification available. National Instruments provide various certification programs, but for the new engineers, for the new programmers, and for the beginner level, you can go for the CLAD exam. You can go for the CLAD exam. This CLAD exam is the entry level LabVIEW certification program. After that, the second level is CLD. If you are experienced, if you have some experience and expertise, so you can go for the CLD exam. And third, that is a certified LabVIEW architect. You are a professional and you want to become a professional developer, so you can go for the LabVIEW architect. So in this time, you are very beginner and you are very new for the LabVIEW, so CLD exam will be good for you. And all those things for this, all these three exams, no need any kind of the hardware. Okay, you can prepare using your laptop and LabVIEW, basic student version LabVIEW by using your laptop, no any kind of hardware required. So for this LabVIEW associate developer, you need Core 1, Core 2 and DAQ simulated module. I will show you how can you add your simulated module for the data. So Core 1, Core 2 and DAQ simulated module. For this developer exam, you need LabVIEW Core 1, Core 2 and LabVIEW Core 3 and simulated DAQ modules like 5 data. So in the Core 3, you will learn how can you create your development architecture, how can you create your modularity and you can system configuration and management part of the LabVIEW. And in this architecture system, you will you need to learn and understand how can you create a design object-oriented task and how can you create one application, user-defined application. You will learn how can you create complete project which you can sell into the industry or you can work with the industry. You will learn if you will apply for the LabVIEW architecture. In this year, I had trained nearly 1,500 students for the LabVIEW. Nearly 89 to 90 students clear their CLD exam. 230 students clear their CLD exam. In this year, I had under training program I provide under the May and June. So now our random topic which I am going to demonstrate you live. So in this topic I will show you how you can acquire the data using the LabVIEW. So for that I will switch my PPT into my computer. So to know and to learn how we can acquire the data using LabVIEW, I am going to demonstrate you. For that, first of all, you need to open your LabVIEW first and then come here and open NI Map. When you will click and open the NI Map, so you will get NI Map, National Instrument Automation and Measurement Explorer. Using this National Instrument Measurement and Automation Explorer, you can simulate your software version of DAQ, because National Instruments focus on the hybrid for data acquisition. The National Instruments product, all kind of products are very good for the data acquisition, and people know National Instruments products for the data acquisition as well. That's why National Instruments has created some simulated version of DAQ where you can learn how can you acquire the data. So now for that, here you will get the device and interface. So click on the device and interface. Here you will get the arrow, expand it. So now my DAQ, this NI my DAQ and NI simulated DAQ is previously simulated here. So I will show you how can you simulate. For that, I am going to delete this my DAQ. Right click in the data acquisition board, click on the create new. You will get a create new window. In this create new window, you will find the device and interface. In this device interface tree, the second one is present. The second one is simulated NI DAQ mesh device or modular instrument. So we will click on the simulated NI DAQ mesh, then we'll hit the finish button. So we will get one more small window for the create channel. It will take 2 seconds now. Create simulated NI DAQ device. So here you can search. So I will search NI MindDAQ. So now you can see NI MindDAQ is here. Double click and open. This one is simulated and NI MindDAQ present here. Now we will try to add one more DAQ system. So for that, click here, come into the create new. Again you will come into the same window. Now click in the simulate. Now here we will target the M series DAQ. DAQ means data acquisition card. DAQ means the data acquisition card. So this is M series data acquisition card we will target, because this is very good. Industrial people and the researchers choose M series version because the data acquisition mode, the range of the data acquisition is very good with the M series. That's why we will choose the M series. Also you can select any one of these, X series and S series, but the M series are the hybrid version. You can use M series with the DAQ and you can use M series with the RIO, very configurable input output device. That's why we target the M series. So we'll select NI PCI 6221 and then we'll click the OK. So it will simulate one new DAQ. So now this one NI PCI. Now I will show you how can we use this DAQ system, okay, simulated DAQ system for the data. So, coming to the LabVIEW, first I will show you how easily you can acquire the data using LabVIEW. The data action using the LabVIEW is a very much easy. You will not find a so easy program, so easy way to acquire the data. This is the front panel of your LabVIEW and it is a block diagram. Okay? When we will start the learning from the basic, at that time I will teach you, at that time I will explain all those things about the front panel and block diagram. So front panel is basically for the user. Front panel, we can design front panel using the control and indicators for the user, where user can insert the input and user can take the output. By using this front panel, you can design your graphical user platform. Now, this is a block diagram. It is for the developer. Here you can design your block diagram using nodes, constant, wires, and other things. Whatever you want to give to whatever kind of control and indicator you want to give to your users, you will create all those things here. And you want to write a program, so you will use the block diagram. I will explain each and everything when we will start from the basic. But here I am going to show you how can you acquire the data. So for that, right click here, right click in the block diagram, scroll down, you will get Express. This first one is input. In this input, this is DAQ assistant. Okay. Take this DAQ assistant and place in the block diagram. This DAQ assistant is Express VI. That means it is a high level VI. That's why it will initialize and it will give you some configuration window. So first configuration window is create new. Here we will create task. Here we will create one task. And our task is, my task is right now, acquire signal. I am going to acquire the analog signal. Which kind of analog signal? I want to acquire the temperature data. So for that, I will use the thermocouple. Create the thermocouple. Click on the thermocouple. It will redirect you for the physical channel. There are three target hardware is present. One hardware is MindMajix and second hardware is PCI card 6221 and third is PCI 6221. So there are three hardware, this one first, this one second, and this one third. So MindMajix is general purpose student data access system. So I will use this MindMajix to acquire my data, temperature data. So I will click here. So MindMajix content two analog input. I will show you inside how can you connect your sensor with the MindMajix. So first we will click to the analog input 0, means channel number 1. Channel number 1, only one channel. Now finish. Now this is the assistant configuration platform, configuration window. Here you can see Express task. This is our Express task which we have designed. Now I am going to show you how can you connect your sensor with the DAQ system. So for that, you can click here connection diagram. So this is your thermocouple. There are two different poles and we are connecting this thermocouple with this analog inputs 0 plus and 0 minus. Analog is DAQ system. DAQ and MindMajix system is differential mode based system, and here platform is not connecting with any kind of ground. That's why we will use differential mode to acquire data. Now click here. The channel name is temperature. Value is 0 right now. This one is our temperature sensor. Now maximum input range is 100 and I am going to create the minimum input range is minus 100. Our unit will be degree centigrade and I am targeting the J-type thermocouple. But now the main thing is here. Either I can acquire one channel, one sample, one channel and sample, or one channel continuous sample. One channel, one sample. Okay. So here I want to acquire one channel and sample. And the sampling rate is 1 kilohertz and the number of samples each time it will generate 100. Now hit the OK button. First it will initialize and it will create the specific DAQ for our target data acquisition. And that target data acquisition is temperature. Coming to the front panel, right click. When you will right click in the front panel, you will get the control palette. Control palette contain all kind of input and output. Control palette contain all kind of input and output. Input means the controllers and outputs indicators. In the LabVIEW, we call controllers as the input and indicator as the output. So here I am targeting 100 samples. Here I am targeting 100 samples to acquire, to read 100 samples. So I need one array to display that data. So for that, I will come into the NXT style. I will click on the data container. Now take an array. Right click. Come into the classic version, come into numeric and take this thermometer and place inside the array. Now you can write it. Here I am taking one more numeric control, and that numeric controls will control the number of samples. So here you can change the name. This one is the number of samples. We can connect this number of samples. Now we can connect here this data with this array. When you will connect this one, so this dynamic converter will appear automatically. The number of sample is 0. If I will run this value, okay, error, just because my the number of sample is 0. So stop. Let's see. Let's try to enter the number of sample 10. Because the number of sample is 10, so now you can see there are 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 data. Now we can change the range. It's minus 100 to plus 100. Now you can see the minus 100 to plus 100. Now you can right click here. Now you can right click here and you can click on the create indicator. So you will get this array. When you will increase the size of array, so you will get the digital value. It is analog concepts to display, and now I am going to show you how can you display your value in the digit format. So for that you can press the run button. Now our data is this one. So first one is displaying 1.11 degree centigrade. It's displaying the 73. It's displaying the 111 degree centigrade, 115 degree centigrade, 73 degree centigrade, 4 degrees, minus 70, minus 117, minus 118, minus 6. Okay, so these are our sample which we had acquired, temperature data which we had acquired. Now I am going to show you the data in the form of waveform graph. So now right click in the front panel, come to the graph, and you can take a waveform graph here. Now the waveform graph in the front panel. Whenever you will take any controls and indicators in the front panel, so the control indicator terminal will automatically appear in the block diagram. Terminals will automatically appear in the block diagram. Okay, by using this terminal you can connect your functions. Okay, by using this terminal you can connect your functions. Now run. So this is 10 samples which we had generated, we had acquired. We can increase the 10 samples, okay, into the 100. Now look at here. It is second here, and it is amplitude. You can say it is degree centigrade. You can say it is degree centigrade this one. Okay. So right now the maximum is 116 degrees centigrade and minimum is minus 118 degrees centigrade. And for that it takes 0.01 second. 0.01 second. Now let's see. For the 100 sample it takes 0.1 second. If I will acquire the 200 data, 200 samples, okay, so it will be 0.02 seconds. If I will acquire the 1000 data, so it will take 1 second to simulate. Now look at it, it's taking time. Okay, 1 second to acquire 1000 data. Let's see if I will take the 2000 data, so it will take 2 seconds to simulate. So in the CLAD exam, they will ask you if the sampling number is 1000, if the number of sample is 100, so if the number of sample is 2000 and sampling rate is 1 kilo. So how much second it will take to display or it will take to simulate? So that will take 2 seconds. So in this way you can acquire the data very easily and you can store your data. Now if I will right click here and I will come into export, so you can export your data using the Excel sheet. There in my PC there is no Excel sheet, so I cannot show you. But you can export your data is Excel sheet, ADMI file image concept. So now it is data action based concept. Now I am going to show you how you can acquire the data by using the API mode. If you want to go for CLAD exam and you want to become a good programmer, so you need to work on the API based data acquisition system, because national instruments we can use the API version. Because when you will use the API version, so you can control your target very easily. Why I am going to show you. You will learn using this example. So for that, right click and come to the measurement. In this measurement, you will get NIDAQ match, match data action, take create channel, timing, start, read, Stop. Now make connection. The reference output is a reference input. Task out. Task in. Task out. Okay. Reference input output. Connect like this. Select all. Right click on the label. Control A and Control U. By using Control U, you can organize your all those functions. Now error out to error in. If error will appear anywhere, so it will inform and abort the program. Here I want to acquire the voltage and allow input voltage will try to acquire the temperatures and allow temperature thermocouple. Here right click, create constant unit is degree centigrade. Here the thermocouple type is K type. Minimum and maximum. Right click, create constant minimum and maximum. Now select all. Label. Labeling is very important. Why? Because by using the label, you can understand and you can design your program very effectively. Okay, using the label, you can change and configure your software, your program. Now right click, create physical channel, create constant. Here, the physical channel means the hardware which is connected in our PC. We will target that hardware here. Okay, here the timing sample. So here the sampling rate, create constant sampling rate is here 1000 and number of sample, create sample per channel, that is the control, and create constant, and that is finite sample. Here we are not taking one sample on demand or one sample software demand. Here we can take the finite continuous sample and hardware time single in point. So here I am connecting the finite sample and press Control A, Control U. Now all these things are organized. Now come here. Here I want to acquire one channel and sample. One channel and sample. For that I will click here and allow input channel, one single channel and multiple sample. And here I want to see the data in the form of dBl. Okay, in the form of dBl. Later I will explain in the class what is the meaning of dBl and what is the meaning of the waveform sample and duration. So here I can, after that here the number of sample per channel is present. So I can right click, create control, number of sample per channel. So here the sample per channel, we can change it into the constant, and we can sample per channel is 1000 and the sampling rate is also 1000. Sampling rate is 1000, sample per channel is 1000. It is a minimum value and it is a maximum value. Okay, but remember one thing, we are acquiring the virtual data. So it is possible our software will not follow this range just because we are not using the real-time hardware. We are using the simulated version. Here you can right click and create indicators. Next, if you will talk about the CLAD exam and detection, how many samples, how many data, if you want, okay, we are generating, if you want to know. So for that you can right click here, you can come to the array, you can take array size, connect here, right click, open the label, create indicator, array size. Let's come into the front panel. Before that, here click here. Now when you will click, so you will get this browse option. Here I am targeting my device 1. So what is the name of that device? The device name is PCI6221 and I am targeting analog input. Here I am targeting analog input 0. Let's come into the front panel. All these things are set here. Number of sample per channel 5. So it will, okay. Now we can acquire the 5 sample. If I will write 19, so we can acquire the 19 sample. Okay. So in this way you can acquire them. If you will when you will prepare for the CLAD exam, so you will find n number of questions related to this DAQ API base. National students are nearly 40 to 50% questions based on this API based DAQ system. So let's talk about the project. So I have already shared this video where you can learn how can you create your calculator using the event structure. And event structure is very important, and it is okay because whatever I had taught you, I had explained right now. and I demonstrate that is just a polling based method. That's just single normal simple VI. Simple VI. That is not a general and generic VI. That is simple VI. So using this event structure, how can you create the event? You can check using this video link. I had my own YouTube channel where I had posted more than 500 videos for the students. You can learn and you can design this project. How can you create? So here I am going to show you one of my projects I have designed. This is my ATM based concept which I have designed using the LabVIEW. The main concept of this program is, okay, we have designed this program using event structure and state machine algorithm. It is combination of both. First, when you will come into our virtual instrument platform, so this ATM will display, welcome to the virtual ATM, enter your card, insert your card. We don't have any card here, so we have designed insert card. When you will click this insert card, after 5 seconds, it will ask you, it will display one information, insert your name. When you will enter your name, then after it will ask enter your field. When you will enter your 4-digit PIN number, our program will automatically calculate that name and PIN number with our previous defined data set. When it will find the person credential is correct, then it will go next and it will ask you for the insert your amount. When you will insert your amount, so after that it will display the amount. 6 notes for 2,000 rupees, 1 note for 500 rupees, and 0 note for the 100 rupees. It will display because so it is our ATM based target project which we have designed, and it will take your 1 and 2 hours if you want to design. So maybe it can take 5 to 10 hours also if you want to create and design one user interactive based ATM machine. Now here I am going to display the one more project, that is basic child learning apps. This is basic child learning app when you want to design. So you will learn how can you build the library. So basically I am going to display only small part of this program, this project. For that we will come to the LabVIEW, select all and delete, come into the front panel, come to energy style. So what is my target? How our children, how our child learn counting, how they learn counting. You know very well in the class 4 to 5 in the LKG and class 1 and class 2, how the teacher teach our students do the count. They write 2 and they plot 2 bars. Then count 1, 2. If they want to learn this, you want to teach addition concept 2 plus 4. So then you will count 1, 2, 3, 4. Then 1, 2, 3, 4, 5, 6. You will plot 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 and you will write. So this is a basic child learning concept. Here you can design the application for the child, for your children for teaching and learning purpose. We can design it very easily. No need to know about the object-oriented programming. Without any knowledge of the object-oriented programming, without any knowledge of the big graphical programming, Java and other things, you can design this basic child learning application concept using your lab. So I am going to show you. So for that, first I will take one numeric control. Here student will enter the numbers and to display, I will right click, I will come into the array, take initialize array, take dimension size, make a connection like this. It will create the magic for our program. Wait for just 1 minute. Now we will, by using this LED, by using this logic, we can display only one digit element. Now look at here. When the students will enter 1, so it will glow 1 LED. When students will enter 2, so it will glow 2 LED. When students will enter 3, so it will glow 3 LEDs, 4 to 4 LEDs, 5 to 5 LEDs, 6, 7, 8, 9. So on this base, your students can enter when they will enter the numbers, it will display the LED. And now you can see them 1, 2, 3, 4 for counting. Using this way, you can create your logic. So now, it is for one number, I am going to create, it is for B. Now you can take one addition function here, A plus B If you want, so I can share the video link of related with the program. So here it will be A plus B plus B, and output will be here, indicator, and name will be A. Now run 18. So it will display 18. It's only for one digit number. We can teach our students how can they add the one digit numbers. So this one, 4 plus 9 13. So 4 plus 9 13. So you can count. It is the 13 elements doing. So I can teach you how can you create this kind of the project, and inside this we need to create library for each and every concept. Okay. So LabVIEW setup I will share to the student, and always I share my student this Google Drive link. In this Google Drive link, where the required software inside here the LabVIEW is present. So student can download their LabVIEW from this platform and license activators from this platform. Students can download the LabVIEW from this platform. Okay, this is LabVIEW exe downloader. So students can download the LabVIEW and students can download the license activator. I share this video link. By using this video link, they can understand, they can know how can we download. And here this is license activator link. This is the video link. By using this video link, they can know how can they activate their LabVIEW, because our LabVIEW training program is the 30 days training program, 45 days training program. So I take 30 and 45 days training program. It needs to be crack the LabVIEW or activate the LabVIEW using the activators, because the free version of LabVIEW is just for 7 days. Additional course. In this training program, I can share to the student the complete video of each and every day session first. Second, I will share for 1 and 4 manual and exercise CLAD preparation material. So just basic composition of our CLAD preparation materials and previous year question papers. And during that time, training time, I can teach student, I can क्या बोल सकते हैं उसको कि I told to my students in which company they can apply, how they can apply, in which section they can apply, and how they can rate, how they can prepare themselves for application engineers, how they can prepare themselves for the cell engineer, how they can prepare themselves for the technical support engineers, how they can prepare themselves for the training engineers, installation engineers, quotation design engineers, lead generation engineers, and for the resume and everything, I teach them how can they, which kind of project they can use, they can design and they can use, and which kind of company they can apply for the internship. Okay, now what if you want to ask anything, so please. So now I'm going to show you one presentation which I use to teach my students. This is my state machine algorithm concept. So I use this kind of PowerPoint during my teaching the lesson 7 sequential and state machine sequential logic and state machine algorithm. This one is our sequential logic state machine algorithm, where we can learn three concepts: flow through parameters, sequential structures, and error case concepts. So LabVIEW cannot force the order of execution. If you will write 4 different programs and you want to determine which will be occurred first, nobody can say which will be occurred first. Okay, that's because I am working in the LabVIEW from last 7 years, so I can say these both the second and fourth will execute before first. Okay, they will execute very easily because they are a low level VI, but these are the high level VI. So it will take time. In the second concept, the flow through parameters, this is dependent on the output of this. It's okay. When the performance of this DAQ system will finish, then it will start. Okay, because it is dependent on this, but you cannot say, but no one can say the first, second, and fourth, which one will execute first. So for that, we can use the structure-based concept, okay, sequence structure concept. By using sequence structure, we can force the order of execution, but there's some disadvantage. One of the biggest disadvantage is you will not execute till this loop will not finish all those concepts. That is the biggest disadvantage of the sequence structure concept. So we have this sequence structure. One more idea that is also not good. So we can use this error concepts. Okay, if error will occur, so we do. If no error, so we will do something else. Then we will work on the state machine algorithm. Using the state machine algorithm, we can learn how can we design, how can we work. If you need to change the order of execution, so what you will do? If you need to repeat one item of the sequence more often than another, so what we can do? I teach all those things from this way, and after that I have kind of program, and after that we will do hands-on. We will each and everything I teach hands-on. After that I take this kind of quizzes. So my demonstration has been done.